Guys, I've got a problem for us to solve together. Wait! Hey there, and welcome to How'd You Get That, where we solve all your math and physics problems. I'm David, and today I want to do something a little bit different. We're gonna solve a problem. I know, we solve a problem every episode, but today we're gonna go through the process of actually solving a problem from start to finish. And to start it all off, collisions. Here's the problem. A hockey puck is moving horizontally along the ice at 8 meters per second. It collides off-center with another puck of equal mass, such that the first puck is deflected 10 degrees above the horizontal. If the second puck starts from rest, what is the final velocity of both of these pucks? So first of all, let's try to understand what's actually going on in the problem. Let's write down our givens and draw a picture. We have a puck moving horizontally along the ice at 8 meters per second, another puck starting at rest that's of equal mass, and they hit off-centered, deflecting the first puck off 10 degrees above the horizontal x-axis. So what do I want to find? Well, the question states that what is the final velocity of both of these pucks? So that cues me into two things. One, that I'm going to have two answers because I need a velocity for both pucks. And it tells me that I need a velocity, which means I need both a magnitude and direction for each of these answers. Having drawn out this picture, I can now ground myself in space to determine what I want to do next. I know that the crux of most collision problems in physics is the conservation of momentum, which states that the total momentum of all objects in the system before the collision is equal to the total momentum of all the objects in the system after the collision. Since there are two pucks, the momentum of puck 1 plus the momentum of puck 2 initially is equal to the momentum of puck 1 final plus the momentum of puck 2 final. Now remember that momentum is equal to mass times velocity, which we're going to use now. Substituting into the equation to look like this, we now find that, well, we know what the masses are, but we don't know what the velocities are. V1 initial, V2 initial, V1 final, and V2 final. So let's take each of these velocities separately. Initially, I know puck 1 is moving at 8 meters per second in the horizontal direction, so I can describe this vector as 8 hat plus 0 hat. Puck 2 is initially at rest, so its initial velocity is just 0 hat plus 0 hat. Now let's look at the final velocities. I don't know the magnitude of this velocity yet, but I can still break it up into components. So V1 final is equal to V1 final cosine 10 degrees hat plus V1 final sine of 10 degrees hat. And what about the final velocity for puck 2? We'll see that it's been deflected below the x-axis, which means that the y component is actually pointing down, so we need to say that it is negative. So V2 final is equal to V2 final cosine phi minus V2 final sine phi. Now what is phi? Phi is the angle that the second puck is deflected below the x-axis. I don't know what this angle is, so I'm just going to label it phi for now. We'll find it in just a second. The strategy for finding phi is to recognize that not only is momentum conserved in this problem, but so is energy. So the initial energy in the system is equal to the final energy in the system. Since there's only kinetic energy involved in this system, no potential energy, we can say that kinetic energy 1 initial plus kinetic energy 2 initial is equal to kinetic energy 1 final plus kinetic energy 2 final. Substituting in the fact that kinetic energy is equal to 1/2 mv squared, we can make this equation. We can cancel out all those 1/2s and all those m's because they're all equal. Knowing that puck 2 is of equal mass to puck 1 and starts from rest is really important, because we can simplify this equation down to this, and finally say that V1 initial squared is equal to V1 final squared plus V2 final squared. But what does that look like? That looks like the Pythagorean theorem. Essentially, V1 initial is the hypotenuse of a right triangle with legs V1 final and V2 final. This furthermore means that the angle between V1 final and V2 final must be 90 degrees. Therefore, since the angle that puck 1 is deflected up above the x-axis is 10 degrees, the angle that puck 2 is deflected below the x-axis must be 80 degrees. Okay, so now I can rewrite V2 final as V2 final is equal to V2 final cosine 80 degrees I hat plus v2 final sine of 80 degrees j hat. Okay, so now we can substitute all of these velocity expressions into our conservation of momentum equation, getting rid of excess zeros and bringing like terms together, so all of our I hats together and all of our j hats together. It stands to reason that I can break this big momentum conservation equation into two separate equations, one that deals with the x or I hat direction and one that deals with the y or j hat direction. In the y direction, I get this. Since this is simpler than the x direction, which looks like this, I'm going to solve the y direction first. I'm going to solve for v2 final to get this expression. Now I can take this value for v2 final and plug it into the x direction equation. Getting v1 final all by itself, I find that everything on the other side of the equation is just a number, which I can simplify down to this. And I find that v1 final is approximately equal to 7.87 meters per second. Its direction is 10 degrees above the positive x-axis. Now I can take this value for v1 final, plug it back into my v2 final equation, and solve for v2 final. Now don't be concerned about the complexity of this v2 final equation. I'm using the exact value for v1 final here just to make v2 final a little bit more accurate. But ultimately, I'm just substituting 7.87 into my v2 final equation. When all said and done, I found my value for v2 final, which is about 1.38 meters per second, and its direction is 80 degrees below the positive x-axis. In sum, the solution for this problem is the final velocity for puck 1 is 7.87 meters per second at 10 degrees above the positive x-axis, and the final velocity for puck 2 is 1.38 meters per second at 80 degrees below the positive x-axis. If you have any questions, leave them in the comments below, along with suggestions for topics you'd like to see covered in future episodes. Hit that like button, subscribe, and hit that notification bell so you never miss another math, physics, or problem-solving tutorial. Oh, and I also offer one-on-one tutoring sessions online for students of all levels, so if you're interested, send me a message. Thanks so much for watching, and I'll see you in the next problem.